What is an access control list? An access control list, or ACL, is a series of commands that are used to filter packets based on information in the packet header. There are a few key things to know in the creation of the ACL. Normally, ACLs are turned off, but when ACLs are being used, the router looks at a packet header as the packet goes through an interface and decides whether or not the packet will be forwarded. We can place an ACL at 2 points on every interface, as data comes into the router and as it leaves the router. The interface can also have separate ACLs for IPv4 and IPv6, and inbound and outbound for each. Thus, the maximum number of ACLs per interface is 4. One incoming ACL for IPv4 and another inbound for IPv6, and an outgoing ACL for IPv4 and an outgoing one for IPv6. But it is important to remember that each interface can have 4 ACLs, not each device. Therefore, your device can have more than 4 ACLs over multiple interfaces, but still a maximum of 4 ACLs per interface. Now we know some of the basics, we need to talk about the two different kinds of ACLs, standard and extended. The standard ACL is permitting or denying packets based only on the source IP address. That's the only thing a standard ACL can look at. An extended ACL is much more powerful. It can block traffic based on both source and destination IP address. In addition to this, it can also block on source and destination ports. So if you want to block HTML traffic from the 192.168.10 network that's going to the 192.168.70 network, you can do that with an extended ACL. As you might have seen on the last slide, instead of a subnet mask, there was a different kind of mask. This is called a wildcard mask. Generally, we are used to using a subnet mask, which looks like this. But the wildcard mask looks like this. Instead of using a 1 to match bits in the subnet mask, like we do here, in a wildcard mask we use a 0 to match the bits. The result is effectively the same, but for ACLs you must use the wildcard mask. You can see them again here in use with these examples. When typing ACLs, you can use some keywords to replace using certain wildcard masks. If you need a specific host to match and not a range inside a network, you could type a wildcard mask of 0000, which means every bit needs to match exactly to the IP address. Thus, only one specific host is allowed. You can replace the wildcard mask in the ACL statement with the word host and place it in front of the host IP address. The opposite end of the spectrum is if you are going to allow anyone, nothing needs to match an IP address. You could use a wildcard mask of 255, 255, 255, 255 with any IP address, or you can remove both and instead use the word any. In our examples below, you can see we are using the host keyword in the standard ACL, and that the destination IP address and wildcard mask are being replaced with the any keyword in the extended ACL. The placement of the ACL is also important. When using a standard ACL, Cisco recommends that the ACL is closer to the destination. On the other hand, for an extended ACL, Cisco wants us to put the ACL closer to the source. Let's look at some examples. In this example, we're going to use a standard ACL. Since a standard ACL can only block using a source IP address, Cisco suggests that we should put the standard ACL as close to the destination as we can. There are 2 ACLs they have shown. The requirement is to prevent traffic from the 10 network over here on the left side off of router 1 from getting to the 30 network over here off of router 3. Both ACLs that they show accomplish this, but one is better than the other. And in this picture, they're using these little funnels to represent the ACLs. There's this ACL that's been placed on interface S011 on router 3. While it does prevent traffic from the 10 network from getting to the 30 network, it's also going to prevent traffic from the 10 network from getting to the 31 network down here. The better placement is this outbound ACL placed on G00 on router 3. This prevents all traffic from the 10 network from getting to only the 30 network. The 31 network could still get the traffic if the first ACL that's up here was not in place. For extended ACLs, we have more flexibility. Now we can filter based on source and destination IP addresses along with the source and destination ports. Because of this, Cisco says that the extended ACL should be placed as close as possible to the source of the traffic. Again, we have two examples that they're showing. We want to block FTP and telnet traffic from the 11 network down here from getting to the 30 network over here. There's two ACLs, again represented by these funnels that they're showing. The first is this outbound ACL on S010 on router 1. This will end up looking at all traffic leaving router 1, headed elsewhere, and evaluate it to see if it can be forwarded. This does accomplish what we want, but it does it inefficiently. Placing the ACL here means that traffic from the 10 network down here is being looked at too. If we place the ACL instead at G001, now it will only evaluate the traffic coming from the 11 network down here, and it won't evaluate the 10 network traffic. If the traffic from here is FTP and Telnet, then the traffic will be blocked. The next part to know about is named versus numbered ACLs. Both standard and extended ACLs can be named or numbered. Traditionally, numbering was more common, but naming is what Cisco seems to prefer now. The numbered ACLs have certain ranges. The standard ACLs are numbered from 1 to 99 and then pick back up at 1300 and go through 1999. The numbered extended ACLs go from 100 to 199 and then continue at 2000 and go up to 2699. The named ACLs can be anything alphanumeric, but no spaces or punctuation. While it doesn't have to be, Cisco suggests using all capital letters to distinguish the ACL. Below are some examples of what they would look like when beginning to enter them.
In this video, I will be showing how to configure standard ACLs and extended ACLs in a packet tracer template. The simulated network contains networks for the business networks and VLANs containing HR, IT, and management networks. It also has a remote web server along with a remote client on the internet. First, we will be creating standard numbered ACLs. For our first scenario, we will be creating a standard ACL to allow only the IT network and management networks to access the internal server. First, I console into the R1 router and create the first standard access list using the command IP access list standard, followed by standard access list number 1. Then I specify the networks to permit, which are followed by the proper wildcard mask. At the end of the ACL is the implicit deny, which catches all traffic that does not match. Using the show IP access list command, I can see the access lists that have been previously created. Then I apply the ACL by using the IP access group 1 out on the G00 interface, which will inspect all traffic leaving the interface. Standard ACLs should be placed as close to the destination as possible, which is why it is applied on the outbound interface of G00. This ACL ends up denying access to the 10 network for the unspecified networks because standard ACLs do not specify a destination address. Finally, I test the host from the HR and IT networks by trying to use FTP. This test shows that the HR network cannot access FTP, while the IT network can, which shows that the ACL worked correctly. For the second standard ACL scenario, we will be preventing the IT network from accessing the HR network. First, I console into router R1 and specify the standard access list with the number 2. Then I specify the networks to deny, which will be the 30 network. The last line will be a permit any statement to allow all other traffic. For this ACL, I will be applying it to the G01.20 outbound interface because it is the closest to the HR network. Finally, I test connectivity between a server on the 10 network and the HR network, which proves successful. Then I test connectivity between the IT network and the HR network, which is denied, showing that the ACL was effective. Next, I will show you how to configure named extended access lists. For the first scenario, we will deny all incoming ICMP traffic from the internet. After consoling into the router, I created an extended ACL using the IP access list extended command, followed by a name for the ACL. In the ACL configuration mode, I add a deny ICMP any command to deny all ICMP traffic, followed by a permit IP any command to allow all other traffic that isn't ICMP. Then I apply the named extended ACL to the inbound interface serial 000 because it is the closest to the internet. Next, I will test the ACL by attempting to ping the public web server from the remote client, which proves unsuccessful because of the ACL blocking ICMP traffic. Then I access the web page of the public web server from the remote client, which proves successful, showing that the extended ACL is effective. For the second extended access list scenario, we will deny the HR network from accessing Facebook.com and the internal FTP server. First, I will create a named extended ACL with the name HR restrict. Under this extended ACL, I will add a deny statement specifying the protocol, which is TCP, followed by the IT source network and wildcard mask, and finally the destination host and service, which is FTP or port 21. Next, I will add two similar statements to block both port 80 and 443 traffic to the Facebook web server. Finally, I add a permit IP any statement that allows all other traffic to be permitted. Next, I apply the extended ACL to the G01.20 inbound interface because it is the closest to the HR network. Next, I test the ACL by attempting to get to Facebook.com from the HR network, which fails. I also try to access the web page from the IT network, which is successful. Test FTP, I attempt to sign into the FTP server from the IT and HR networks. From this test, it shows that the HR network is denied, while the IT network is allowed, showing that the extended ACL has been applied correctly.